Okay. I'm going to explain two events in the next months. Firstly, the EuroPython 2017. EuroPython is just the biggest event for Python in Europe, and for the next year, this event will be organized in July in Rimini, in Italy. You're cordially invited to participate to this event, and of course you can come with shirt, everything if you want to go to the beach. So, yeah, of course, you can propose. The call for proposal will be open in few months, but the date will be in July in Rimini. Okay, there is a Twitter account, Twitter account, the website, just a mailing list if you want to receive some notification about the future of the event. Just that. And of course, with Rimini, you're in Italy, you have Florence, if you like to see Florence, Bologna, Venice, and the other cities. Okay, so I'm going to pass to the next event. That's not very important. It's my first name, last name. I'm Stefan. I'm going to explain you one thing in February in Belgium, in Brussels, that the FOSDEM 2017. It's just a small event where we have beer talk, beer hack talk, and the rest. Of course, it's just we try to improve the open source software. In my case, that's just Python. FOSDEM is just 5,000 hackers, 400 lecturers, unlimited beers, of course. That's totally free. No need registration. You can come. Yeah, that's true. But you have to pay them. So that's totally free. You have the website, fosdem.org. The topics. We have some topics about LLVM, security, PostgreSQL, MySQL, IoT, configuration management, Go, Ruby, Perl, of course, Python. Okay? Example, it's the smallest room in the FOSDEM. We have 1,000 people in this room. But welcome to the Python FOSDEM 2017. We are 500 Pythonistas, 16 lecturers, unlimited beers, of course. And that's the room, just the room. That's the biggest event, the biggest room in the FOSDEM. We have the FOSDEM. I have one room. I'm the organizer of this room, and I receive to have I have 500 people. So of course, you can find some goodies, T-shirt, plush, brochures from the PSF, and we can make some pictures and the rest. Of course, we have some free beers. Yeah, the recipe is just on Twitter, on internet. There's free beer. I think it's an original beer from Belgium. It's not a joke. And yeah, you can buy that. And we try to organize a dinner. So, do you know Asterix and Obelix? We are Asterix and Obelix. So, you can add it to your agenda. Please, that's really fun. Just for the date, there is a call for proposal. The deadline will be on the 2nd December of this year, of course, not the next one. And that's all.
Oh boy. So, tooling big events, a case study. That's my name, you don't need to remember it. Do pay attention because this is going to go really quick. Tokyo, 2020, late July, it matters. Why? Well, you'll find out shortly. Tokyo 2020, Olympics, Paralympics, but somebody has to run it. They need software. Announcement, the official, common, business-oriented, because you know there's one obvious way, language of the Tokyo Olympics and Paralympics is Python. $2.7. Sorry, programmers. No gold for you. Just job security. Arigatou gozaimasu.
All right, my name is Alex Williams. I work here in Toronto at a company called EventMobi. We do technology for events, conferences, trade shows. No Olympics just yet. Things like PyCon. Actually, if you've used the conference app, you've used the product that I work on. So shifting into the topic, let's talk about code review. Does anybody not do code reviews at all? Okay, I've got a separate talk for you guys. This talk is for the people who do code reviews. So when we're doing code reviews, has anybody done a formal meeting, a formal inspection, where you get a bunch of people in a room together, you look at the code, you go through it as a group? Yeah, I see 2 people. Okay, great. Don't do those. They're actually the least efficient way of reviewing code. Multiple studies have, in fact, confirmed this. So we're going to do code reviews, but we're going to do individual code reading, where each developer reads the code themselves. So a couple of different methods you could do to do that is a personal checklist, for example, where each developer maintains their own checklist of things that they look for in code reviews. Now, you can share these checklists between the developers on your team so that people are collaborating on them, but ultimately, each developer maintains their own list of things they look for. A different type of individual code review would be a systematic review. This is where the code author actually writes an additional walkthrough about how to review their code. So they talk about why some decisions were made, where to look for certain things, and different parts of the code base that they could use as a reference to help them with this original review. A similar but related one is a use case review. Again, the developer writes a walkthrough, but this time they talk about how the code is going to be integrated into the system. So it's kind of like a user story, except the users are the other developers on your team. Now, one study compared these 3 different kinds of code reviews and found that checklists were by far the most efficient way of finding defects in your code. But the interesting thing was, of the 3 different styles, in fact, the different styles tend to uncover different kinds of issues. So if you really want to get rid of issues before they get to production, you should have multiple reviews, but each review should be done in a different style. Let's talk a bit about time and speed. Going back to this graph, we look at around the 60-minute mark, so this goes up to 90 minutes. Around the 60-minute mark, the number of defects found seems to start to drop off, and by 90, the line is almost completely flat. And again, multiple studies have found this effect as well, that after about 60 minutes, reviewers tend to get tired, and they're finding less issues for time spent. And actually, by 90 minutes, they're not finding anything at all. So we've got the amount of time you spend. We should look at how fast you go through a review. This is from a review done at Cisco, actually a group of code reviews, a review of reviews, a meta review, if you will, looking at the inspection rate and the number of defects found per 1,000 lines of code. And so aside from some outliers, this graph tends to show a decrease as the inspection rate increases. The number of defects found per 1,000 lines of code tends to drop off, as you would expect, really. So combining that information with the previous graph, they looked at the size of reviews that were done. And so this is a graph of between 0 and 1,000 lines of code under review, and that around 400 lines of code, actually even earlier, between 200 and 400, the number of defects that you find per 1,000 lines of code is directly correlated to the size of the review. And again, larger reviews, more time, people get tired. So reviewing all of that, as a reviewer, you should have a personal checklist that you are maintaining to help you get the most for your time doing code reviews. You should review as slowly as is reasonable for the review. And who knows what that is? I'm being intentionally vague about that. You shouldn't spend more than 1 hour on a review, because after that, you're probably going to get tired. You're not going to do as good of a job. For authors, if you're writing code, you should try and make your changes 400 lines or smaller. to maximize the efficiency of the people reviewing your code. And you should probably write a guide or a walkthrough for other developers so that they can review your code more efficiently. One final thought, if you're using linters or static analysis, this is great because any issues found by those tools are issues that your reviewers aren't wasting their time on so that they can focus on the larger problems in the code review. Thanks very much. There's some citations on the slide. I'll post it on Twitter, MAlexW, so that you guys can see it. Thanks a lot.
So I don't have slides prepared, so I'm just going to pull up this GitHub page. So about 8 months ago, I was somewhat drinking a lot with a couple of friends, and I said, you know what, I think Go's syntax looks exactly like Python, and all stupid people would just use Go instead. And, you know, the night wore on, and then I got a couple random text messages from my friends saying, it doesn't look the same, and that was a stupid comment. So I started this project, which I call 5 Little Monkeys, where if you're familiar with the nursery rhyme, just see if I can get down, it basically goes like this. There's no, let me just open that one, sorry. Where's the text document here? So here, we'll open up the Python version of this. So basically, it goes 5 little monkeys sitting in the bed, one falls down and knocks its head. And I thought, this is a really great way to show different things than just a hello world statement. Because frankly, everyone sees hello world, there's no training involved in that. So I decided to start a project where basically any new fun programming language that comes out, I write a small script that basically does a for loop and figures out how to exploit this actual thing. Here, I'll show you the test, which will actually show you what it's supposed to look like. And this, right, there's the text document. So this is what it's supposed to export out as. So it does these cool things like for loops and all this kind of stuff. And if you look through the different source codes here, sorry, there's 2 mice. It's kind of annoying. So let's look at, you know what's a fun one? Let's look at it in SCSS. So the idea here, though, is that we have all these really powerful programming languages. Even CSS can do this now, which is scary and interesting in multiple ways. You still have to add some HTML like here at the bottom. But the idea here is to take yourself out of a comfort level and to actually produce something in a programming language that's simple to do that you could probably learn in about 2 hours, but that's something that's not complicated, or it's not just hello world. So I've been doing a lot of these types of things a lot lately. A little while back, I had this long discussion with programmers about how much time we spend learning our craft. Because in the end of the day, we are a profession, and we have to spend some time on professional development, even though really no one wants to do that. And this has become that thing for me, and I think it's really important that we all do that because it helps us grow. Let's see if there's another one I can show you. Wrong mouse. That's interesting. Here is an example of something. So another good example of this is Swift. Now, Swift is one of those annoying programming languages that decides that every version should have a completely new syntax. So one of the great things about doing this type of script is that you can run it based off a test, and within seconds know that, yes, they changed how if statements are run, or yes, they changed how for loops are done, and things of that nature. That's pretty much it. I hope you liked it. Okay. It's a little embarrassing for myself, but sure.
I must know.
So this is what Go looks like. So yeah, it is different. Pardon?
What are those squiggly?
These things? Go, all right, I thought I might have had a little bit too much to drink that night. I was thinking, I think Rust is actually closer. I can't remember. I was thinking of some programming language, but I was so fixated on that it was. Yeah, so this is Rust. It looks the same. I can't remember which one it was. This is, of course, Java. Well, this is Node.js. Where is it? Yeah. I might have been thinking of Swift, more than likely. But yeah. Okay. Python. And maybe, here's CoffeeScript. if anyone's interested, how CoffeeScript actually has a very similar thing to Python, except for no colons. But yeah, it actually produces tab. Like, there's this interesting thing in programming languages now, which is like the idea of like white space is like the new line operators and things instead of having like colons. I actually find that really fascinating. Has anyone been to, I know this is bad to bring a Perl thing up at a Python conference, but Damien Conway does these amazing talks about how the syntax of Perl has evolved through kind of every iteration of itself and why they chose to do that. There's another thing I do, which is basically trying to figure out threading in every language and how every language produces it. And it's quite fascinating. You know that Python's doing it right because every other programming language is moving to a Pythonic syntax for threading. And it's nice to know that kind of stuff. Like, because I remember about 4 years ago in the Perl community, the big thing was threading was going to be exactly like how it's done in Java because Java was doing it right. And now threading is in Perl, threading in Python is the exact same thing as Python. So yeah, anyways. Okay.
So let's go ahead and tackle that thing. First, I want to thank James because he convinced me last night to go for a lightning talk. Thank you so much. It's a great opportunity. So my name is Beth, and I came from Chicago to this PyCon because I really love Python community, and this is actually what got me started into thinking about learning how to code and like kind of getting into all these challenges and all that cool world that's really interesting. So my background is medical. I went to medical school, then came to the States, then I was like, cool, let's explore other opportunities. So now I'm gonna compare my experience of learning coding at a coding boot camp to medical school because they're kind of hard and stressful and challenging, so let's see how that goes. So I said I'm from Chicago. Chicago's a cool city. Then this may sound like hello from the other side to you because you're like all probably or most of you are well versed in the industry and kind of forget the beginnings. But it's great to kind of, for me as a beginner, to see something to shoot for or like where I want to go. I really want to be like all that interesting people like who are making cool things. So the other side, the beginner's side, looks like this. I'm currently going to a coding dojo, which is a coding boot camp, very intense, very challenging, to a beginner, but probably like lots of basic stuff. So the first challenge we're facing is the time and the pace. The time is very limited, and even like if we try to kind of have access to the place 24 hours to kind of get caught up on our assignments and like our stuff that we need to learn and the code reviews and this stuff, it's still not enough time. Also, the pace is very fast, so it's true that the perfect way to learn is like on your own pace, slow and steady, but you want a push to learn, to get things going, to go to the next big thing in your life. So the pace is crazy, but you need to keep up with it because when you're coding, you're mostly on your own. People trust you to kind of manage your time properly. So we learn how to keep up with the pace, which is really crazy. The other thing is we have classmates, and classmates are kind of probably similar to the industry coworkers in a certain way. You know, you have like people from different backgrounds, culturally and professionally, and sometimes you feel like, although we're not like gonna be friends, but we have to put up with each other and kind of learn how to just kind of accept each other the way we are. And sometimes kind of learn about things like how to show empathy and all the stuff that like we were taught in medical school, and how to break bad news and how to deal with people and how to establish rapport. Sometimes you'll face challenges with people who are not familiar with all these things and you have to kind of put up with them. Sometimes you gotta inject your background in the environment and like see how you can probably have somebody learn from you while you're actually learning something from them. So this is one of the things that I'm currently encountering, which is really interesting and still going. Next one is a lot of walls. So learning coding in a coding bootcamp is hitting a wall, then just getting done with the other wall to hit another wall too. Or like you find a bug, then you have an existential crisis, and all of a sudden it's just a typo. So this is probably my daily life right now. And the last thing is probably, a very important thing is a challenge of, like, as somebody who thinks about health all the time, staying healthy while I'm learning to code, and in the near future, being in the industry, like, there's a lot of sitting, a lot of like forgetting about how many calories I take today, and staying healthy, being active, standing, and keeping like active, not forgetting yourself. So all these things were kind of always in the conscious when we were in medical school, although it's long hours of studying, but it was probably like over 5 or 4 or 7 years, a long time compared to like just kind of 3 months. So getting into bad habits of snacking and like unconscious, say, neglecting yourself, not being active, and not like caring about staying like mentally healthy, not like crushing yourself whenever you hit a mistake, or like whenever you find a bug that you cannot fix. All these things kind of like come to my mind, like, and I want to keep them in my focus. They're easy to forget. So despite all these difficulties, do I regret going through such an experience? No, because I think it's really worth it. And although it's very difficult, but I have to figure out a way to enjoy the ride, because there's a lot to look forward to. And this is actually one of the reasons I'm here at PyCon Canada. It's because I'm learning, and when people like talk about Python and stuff, and I feel like, wow, yeah, that sounds familiar. I can relate to that. And see a lot of role models that keep me motivated to enjoy the ride and keep going. Thank you. That's all.
I'm going to try and do the impossible and do a tool talk in 5 minutes. All right, so American Fuzzy Lop. It is a breed of rabbit, but it is also a security fuzz testing tool. Fuzz testing, in case you don't know, it's when you generate random inputs to your tests instead of hand choosing your variables. So you say x equals 10, then you test your program, and it fails. Okay, that's your hand one, but instead you can generate the random inputs. So that's basically what we're getting at here is fuzz testing. We're going to take an executable program, we're going to generate random bytes, throw it in on standard in, and see if the program crashes. So we're not doing anything with business logic. We're not doing anything to do with your problem space specifically. We're going to take a generic fuzzer that will work against any programming language, any binary you happen to have. As you can imagine, just generating random bytes doesn't get you very far because the key space is so huge. The chances of you finding the random string of bytes that will cause your program to crash is very low. So you have to be a little bit clever about it. And so various fuzzers do various sort of introspection, analysis of the code, and they try and do very clever things. And I've lost my. That was fun. There we go. So they do clever things, but those are largely academic exercises. In practice, they run awfully slow. So the guy who made American Fuzzy Lop was one of those academics. He had written many of these very fancy fuzzers, but in his perspective, even if you can make the fuzzer 10 times better at finding bugs, if you're 100 times slower, you still lose out. So instead, he wrote a very simple one. It's very simplistic compared to the others. It uses a bunch of just heuristics that have generally found bugs, so things like bit flips and that sort of thing, but also a genetic algorithm to mix and match the cases in order to optimize the number of branches you hit by doing your random fuzzing. So let's see it actually in use because I'm running out of time. So the example I'm going to be using is I'm going to be fuzzing a Python library called PyHocon. PyHocon is the Python implementation of is a Python Hocon reader writer. Hocon is a mix between you can think of it as a mix between YAML and JSON. It's a configuration file language. So what we're going to be doing here is we're going to be generating random bytes, trying to decode them as Hocon. trying to decode them as OCON, re-encode them back to the original bytes. So you can see here we're round tripping it, we're parsing the random bytes that come in, setting them back out, making sure that nothing crashed. And if it does, that's cool. So this is the wrapper code, that's all I had to do. I'm just round tripping here and it reads from standard in, and if it dies, it dies. That's great. And now I go to run the, let's see here. I go to run the command. The command to run it is PyAFL. This is a Python instrumentation for AFL because, again, AFL doesn't have any understanding of anything. It expects a binary that reads from standard input. This just pretends, essentially, gives that instrumentation. So I give it an output folder. I give it an input folder. The input folder, what you can do, instead of having it seed your genetic algorithm with just pure random bytes, you can seed it with example files, a corpus of information and data that you have. So what I did was I just took the 5 examples that they have on the PyHocon documentation page, put them into a folder, and pointed at that. They're just the simplest hello world stupid examples of a configuration file. And pointed at my AFL test.py, which is what you saw there. Suddenly it's running. This gives you this nice curses display. It tells you how long it's been since it found the last crash. It also tells you, it can detect things that like hang your program as well. And so you see, it's done. This ran on a single core. I just left it in the background running for a week. I forgot it was there. Then I remembered, and it had found 1,450 crashes and had narrowed them down, realizing that there's only like 8 actually unique ways it was actually crashing. Of those, you get a nice just input, like this is what I put in, and then you can try it yourself and verify that yes, it is actually a bug, and you can debug it. So it does a bunch of different checks. It does your bit flips. It does a bunch of slices, but I am running out of time. So we found a bug. It was non-trivial. It's in the middle. It's in some very dense code. It passed code review in an open source library. So we found it, and I didn't have to do anything. That's the best part. Best part of all of this, I didn't have to know anything about PyHocon except for like what is their serialized, deserialized function. I didn't have to know anything about AFL or how it worked. AFL doesn't need to know anything about whether it's Python or C or anything. It's all agnostic to the whole thing, and it's free glory because I found a bug. I'm now a contributor on this project. So AFL, it's very awesome. It's well documented, well thought out. All the docs are there. You can read exactly how it works. It's awesome. I'm out of time, but it's fantastic. And go out and get the free glory for yourself.
Hi, everyone. This lightning talk is called Don't Use This Slideshow. We're at PyCon Canada. It's Sunday, November 13th, 2016, and I am James Powell. Now, some of you may be unlucky enough to follow me on Twitter. I'm Don't Use This Code on Twitter. And one thing that I do is I give an enormous amount of talks. I often do these at the very last minute. I put the materials together after already submitting the proposal, because after I submit the proposal, I realize I didn't really want to talk about that. Now I have to figure out something that fits both the proposal and the title and the time allotted. I'm sorry for this. It's probably my fault. Maybe I should put more presentation to this, but as the way it works, these talks get put together in the very last minute. Just for context, this year I've spoken at PyCaribbean, PyData Amsterdam, PyData Berlin, Strata in San Francisco, PyData in London. I gave a lightning talk at PyCon. I spoke at RStats, an R conference in New York. I spoke at PyData San Francisco, PyData Carolinas, a conference in New York called PyGotham, PyData in Chicago, PyData in DC, here at PyCon Canada, and I might actually need to speak in an event next week. Each one of these were brand new talks put together at the last minute. So I need some way to write slides really quickly because I'm giving too many talks and they're all on brand new topics that I've never presented before. So I'm going to show you a little tool that I wrote to put slides together. But first, do not use this tool. Please don't use this tool because the tool I'm going to show you is still under active development, and I would absolutely hate for you to put together a slideshow and then a week later realize that I've changed something about the tool and you can't actually present the slideshow that you put together anymore. So one great thing though is you can't ask me for my slides because you have no way to present these. Like everyone at conferences are like, oh, is it in PowerPoint? Oh, is it in a Jupyter Notebook? Nope, I wrote my own tool. So good luck doing anything with my slides if I give them to you. So one thing I want to show you is some of the custom features of the slideshow tool that I have. Just the ability to give in-depth technical presentations where you can have custom keys, so I can press a key on the keyboard and it'll pop up a window because there's always supplementary material, where I can have like a little timer in the bottom corner so I can figure out how long I should be. So I'm about 2 minutes and 27 seconds into a 5-minute talk. The ability to take screenshots of my slide, so I just took a screenshot of the slide. The ability to, I thought, why not? Why don't I have like a prompt so I can run commands from the command line during a slideshow, because that might be useful. And the ability to have all sorts of completely useless tools like that. So here's a question of how it works. I'm going to open up another slideshow presentation and tell you how this works. So here's an example presentation. It's a very simple presentation. You can see this slide. It's from a library that I wrote called Emlyn that should be on GitHub very soon, but is in no stable fashion. It's named after a friend of mine, Emlyn Clay, who, I don't know why I named it after him, but I decided, what's the most obscure and pointless name I can give to a tool so that as few people as possible will actually use it. Let me show off a couple of features for you. So in the slideshow presentation, each piece of the slideshow presentation is just a line separated by a new line. So this is the actual file that I'm using to present this slide. So you can see that's the slide I showed you, then the slide, and you can see this here on the screen down here is the slide with the custom key binding that popped up the window with the slideshow itself. It has a certain lo-fi aesthetic to it. It's very similar to a tool called Scent by the guys from Suckless, which is, it inherits some of the simplicity and some of the aesthetic from that tool. That was another custom key binding. It has comments in it, so I can make comments in my slide. I can have notes that look something like that. I have backslashes in it, so in that original file, each block of new line delimited text is a slide, so I can put together slides really quickly. I can do things like header and footer, so it has little directives. So this is what it looks like in the slideshow itself to add a header and a footer. The directives in this are for control. So see, I can add a header and footer to this. I can change the color of the header and the footer. I can change the color of the background. I can change the color of the foreground. And I can do all sorts of funny things. I can use any color that's understood by X, so I have a lot of colors to choose from, or I can give our hex-based color codes. There are certain principles to this tool. It's supposed to have a certain lo-fi aesthetic. It's supposed to be text-only presentations with very limited markup, like that underline via Pango. There's a use of emoji for, there's a certain aesthetic to it. For cases where you might otherwise use an image, the goal of this is to actually be a fully programmable slideshow tool where you can embed a Python interpreter within a slideshow tool. So you can do all sorts of really crazy things I'm just about to show you. Written in minimal lines. When I put together this example, it was 700 lines of Python code to give you all these features with very few hard dependencies. So outside of dependencies on, right now it's dependent on GTK, but that's about 20 lines of code that could be replaced to work with any other windowing system. And let me show you a couple of neat things that I can do. So, I can do things like change the color of the background, change the color of the foreground. I can write these directives in all sorts of fashions in a very shorthand form, so I can write these slides just as quickly as possible. I can actually write the directives, like for the foreground, using things which are Python code. So this evaluates this Python code and then uses that. I can even do things like have it shell out to a program, which will then give me things. So I can have parts of my slideshow, like the header, the footer, or the main content, that's the result of shelling out to a program and then getting the contents of that slideshow. For example, this header is just random.random called, so it's refreshing every single second. Isn't that kind of cool? So for example, I can easily add the current time to the top, because that's just datetime.now with some nice formatting as the header evaluated as Python code. How many slideshow tools can do that with literally one line of code? How many slideshow tools can even do that? How many slideshow tools do you know that you can add like the current time at the top? Exactly. You can do some really fancy things. You can actually do this on multiple lines. You can refer to other components that are calculated in this. So you can see I have the color of the, this is a little weird. So the header is actually the representation of the color of the header. The header, its foreground color, is actually the same color as the foreground text, which is how I can do some kind of neat things. These are evaluated in lexical order, and there's some catches. As I can tell you, this is a very rough tool. There are some interesting special directives. So every time you enter a slide, you can run some custom code. So if you look at my terminal, every time I enter this slide, you can see it says slide entered. Every time I exit the slide, it says slide exited, so I can get timings of the slide. And I'll show you that in a second. You can see every time a slide is refreshed, it refreshes. So you can see it's actually printing out the current time when the slide's refreshed. And one of the neat things I can do is if we go back to the original presentation I gave, you can see in the terminal, I use the enter and exit to get timings for the slide. Because now I know every time the slide's entered, so I can actually time my presentation. And you can see every time I go through a slide, it's telling me how much time did I spend on that slide, how many runs did I do through that slide, so if I revisited it, what's the fastest I've been through that slide, the slowest, the average time, the progress. And the really neat thing is, it even outputs it to a directory. So this is the number of times I've prepped this presentation and all the timings. So if I really wanted to prepare for a presentation, which I don't because I don't, I could have a lot of really useful tools to say, oh, it took me 32 minutes and 46 seconds, and this is the slide that I spent the most amount of time on. The next feature I want to add is, because I can arbitrarily add code to a slideshow presentation, I want to add a custom header so that at the beginning of the presentation, you go to a little Flask app that I'm writing, and you can tell me when I'm going too fast, and it'll pop up on the screen. And I suspect that'll take about a weekend of time to do. Thank you.